Everyone, this is lesson 31. I'm finally getting to it. Unfortunately, as soon as you guys were walking out, I erased the board, so I don't know which problems you asked for, so I'm going to go through and do many of them. Hopefully I'll hit most of them that you asked for. The first one is one of those kind that I said that we're not going to be doing. They're called abstract rate problems, and they're from lesson, I think it's 28. So when you see that, you can skip it or you can challenge yourself and try them. So I'm going to do one for you just so that you can see. If you want to go back and watch the dive CD for lesson 28, that works too. So just making sure my thing is playing. Okay. The Austrians marched M miles at P miles per hour and arrived there 1 hour early. If they had started 5 miles further away, how fast should they have marched to get there on time? All right, these are basically very confusing, but we know that distance equals rate times time, right? So we're going to keep that formula in mind as we do this problem. So they marched M miles, so that's their distance. So we can say their distance equals M. It also says they went P miles per hour, so their rate is P. I'm just going to set up as much as I can. And so we can figure out time. We can figure out time because we can solve it for time. We can say if we divide distance by the rate, we're going to get the time. So we can figure out the time in terms of these abstract variables. So we're going to figure out our time. It's the distance, which is m, over p. So that's our time. All right, so that's case 1. Now we're taking case 2. If they had started 5 miles further away. So we're going to have a new distance. So we'll just call that ND. New distance is going to be whatever the old distance was plus 5. We're also going to get a new rate. We'll call that NR. Oops, I should have done the new time first because we have to figure out the rate. The new time, it says that they got there 1 hour. Let's see, the first people arrived 1 hour early, so if they got there in time, we're going to have to add 1. So the new time, so we go back to the old time right here, and we're going to add an hour because they showed up on time instead of late. All right, now we can get our new rate. So we're going to go back to our formula, d equals distance equals rate times time. We need the rate, so we know that rate is distance over time. So the distance is m plus 5 over m over p plus 1. And what are they asking for? How fast, which would be the rate. And then you just need to simplify this. We're going to multiply everything by p. So we're going to get mp plus 5p all over m plus p. I think that could be the answer. Let me just check in the answer book. Yep, and it's miles per hour because we're talking rate. And you can see why I don't particularly like these miles per hour. They're not impossible. So I might do them here and there if I do a video. You can try them on your own and see if you can get them. We can go back and watch. This is from lesson 28. All right, next one, number 3. I think you guys can do consecutive integer problems. I'll set the heading up for you if you need help. Find 4 consecutive negative integers such that the product of the first and the third. So we want consecutive integers. So we would say n equals the first. Remember these from Algebra 1? N plus 1 equals the second. N plus 2 equals the third. Oh, we need 4. N plus 3 equals the fourth. And then you just follow along. Find 4 consecutive negative integers such as the product of the first and the third. So we take the first and the third, like this. The first and the third. And then we just keep following along here. And let's see what else we got. First and the third is 25 greater than the product of, so it's 25 greater. So we're going to add 25 onto the end. Then the product of negative 13 and the fourth. And then you're just going to solve these. You're going to get 2 sets of numbers, I do believe, And you only want the negative ones because it's asking for negative numbers. All right, let's go on to 5. Assuming you can do 5, but let's just do it real quick. Find the equation of a line passing through the points 2, 7, and parallel to the line passing through 1, 1, and 3, negative 1. Let's see if I'm looking at that right. 1, 1, 3, negative 1. All right, so it's going to be parallel. So first thing you have to do is find the slope between these 2 points. So you're going to take negative 1 minus 1 over, well, we know the answer already, 3 minus 1, and we're going to get the slope is 0. Did I do that right? No, I didn't do that right. Negative 1 minus 1. Ah, it's negative 2, silly. Okay, so it's going to be negative 2 over 2 equals negative 1. All right, now we're going to write an equation of a line. So we write y equals mx plus b. This is your x, this is your y, this is your m. So you fill those in. So you get 7 equals negative 1 times 2 plus b, and you solve that for b, and you get b equals a 9. And so you write y equals negative x, because this is our m right here. We don't write the 1, plus 9. All right, we've done those for a while, so that shouldn't be hard. All right, finally getting into the ones that might cause you a little bit of trouble. Number 7. So they're giving you a graph. We'll have to talk about this one a little bit. So, you know how you can fast forward through this so it's not as torturesome as watching all the ones in class. We have a parabola, which I'm not going to be able to draw a very nice parabola, that's for sure. That goes through the origin. All right, there's our parabola. Going through the origin, and right beside it, they do another graph. I'm just going to put it on the same one, why not? 1, 2, 2. All right, let me just spread those out a little bit since there's only 2. So 1, 2. And right beside it, it's an identical shaped graph, which mine's not going to be, but it comes through. Let's change the color on that too. It's going to hit at, it should be identical shape, just remember that, look in the book. Like that. It looks more like a V. All right, the first one, the first graph of a parabola, they tell you what the function is. They say it's f of x equals x squared. That's called a parent function. We've talked about these before. Parent functions go through the origin. Parent functions go through the origin, and this one had to be, it moved over 2 spots. So if it moves to the left or to the right, you're going to write the function like this. I'm just going to show you first of all. F of x equals x minus 2 quantity squared. If it goes to the left or right, the change goes inside of the parentheses. If it goes to the right, it's going to be negative. If it goes to the left, it's going to be positive. It's opposite of what you're going to think. If we took this graph and we moved it up, let me just take the same graph and move it up too, like this. If we moved it up, the graph would be f of x equals x squared plus 2, like that. So when you move it left or right, you're going to add or subtract inside of the parentheses. And if you go up or down, it's whatever. If you moved up positive 2, it's going to be plus 2 outside of the parentheses. So we'll be talking about this more later, but this is the answer right here. I'm sure there's a video. This is from, the dive CDs are going to be really helpful this year. I hope. Depending, I was telling Noah I should probably watch them to see how he teaches them, because we probably do it totally different. Yeah, there's not much explanation. So hopefully it's from lesson 31. So I'll just note that, 31. All right, number 9. I wasn't going to do this one, but Noah said that it's still one that he has trouble with. So let's give it a whirl. 9, find the resultant of 5 at 120 degrees plus 7 at negative 35 degrees. Two different problems. Let's set these up. There's one. Well, I got my line tool out. I'll just do the other one. We're going to change them into rectangular form, and then we're going to add them together, and then we're going to change them back to polar form. So 120 degrees is going to be in the second quadrant. So it's going to be 60 degrees short of 180 degrees. So let's see, it's about 45. Let's go a little higher. There we go. And let's make our triangle. And let's do the other one. I could have done these both on the same track, but I didn't. Okay, negative 35 degrees means we're going to go down and complete our triangle. Alrighty, so this is 5. This is going to be 120 degrees right here. So that means what's left is going to be 60 degrees. And this is going to be 35 degrees. We are trying to find this point, the coordinates of this point, so we need the y, how far up and down it is, and the x, and we're going to need the x and the y. So I'm just going to have the numbers for you here. So we're going to do the x first. X equals, you take the length of your segment of your vector 5, and it's going to be cosine of 60 degrees. Remember, x goes with cosine. And that's going to give us 2.5. And y equals 5 sine of 60 degrees. And that's going to give us our y coordinate, which is 4.3301. Now this one's going to end up being negative because this is negative, that direction. And let's do this one. X equals, I didn't put the number on it, 7 cosine of 35 degrees, and that's going to be 5.7341, and y is going to be 7 sine of 35 degrees, and that's going to be 4.0105 150. All right, now we're going to add our x's together. We're going to add these two together, and we're going to add these two together. Let's make sure we have the positive and negatives. This y this time is going to be negative because it's in the negative direction. So when I add my x's together, I'm going to get 3.2341 I hat. You could say right. And if I add my y's together, I'm going to get a positive 0.3151 j hat. Okay, part 1 of the problem is done. Now we have to change it back into polar form. So we have these are rectangular coordinates, so we're going to plot it on the rectangular coordinate system. There we go. And with these, obviously we're not going to be exact measurements. This is the number that we're going to go right. We're going to go over here, 3.2341, and we're going to go up just a little bit, so it's a smaller number, so we're going to go up, and we're going to plot a point right there, and we're going to connect it and make ourselves a triangle. You can see it's going to be a narrow angle. All right, I'm a little bit better with these tools than writing on the whiteboard. All right, now, believe it or not, you have to do the Pythagorean theorem to get this. We know this side right here. I'm just going to erase this. I don't have an eraser. I'll just do that. This side is 3.23. We're going to round that, and this side is 0.32. I know it's a nightmare to do the Pythagorean theorem, but that's your resultant. So if we do that, you're going to get 3.23 squared plus 0.32 squared. In the book they don't round. And we're going to get approximately 3.2494. That's the resultant. That's your vector length. So it's going to be 3.2494. Now we're going to have to use trigonometry. We use tangent. So we'd say the tangent of theta equals opposite 0.32 over adjacent, which is 3.23. And then we're going to do inverse tangent of whatever that division is. So 0.32 over 3.23. We put that in the calculator and out pops the angle, which is 5.56. And you can see it's consistent. It should be a really small angle. And finally, we can write our answer. When we add those two vectors together and then change it back into polar form, the vector length is 3.25 at 5.56 degrees. I didn't even plan on doing that problem. Okay, back to our regularly scheduled program. We are on number 11. I'm going to just do this one because I don't know if the new people ever learn to do factorials. It is a favorite in our class. 7 factorial over 4 factorial, 3 factorial. So what factorial means is you say 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. You can cross out the factors. So 4, 3, 2, 1 goes with 4, 3, 2, 1. 3 times 2 is 6, and so we're going to get 35 is our final answer. All right, that was 11. Moving right along. 13, we need to do logs. All righty. So the first one is, well, there's only one. Log base 3 of 1/9 equals b. Now this is just a rearrangement problem. We can rearrange whatever the base is you're going to put on the bottom. This is going to be your exponent. And I hope you watched the video for this one. The exponent would be b equals 1/9. Well, 3 to the what power gives you 1/9? Well, it went in the denominator, so it's going to be a negative power, so b is going to be -2. This is from, I have to turn the page here, this is from lesson 26. So if you want to go back and look up the logs, this is from lesson 26. It was a class favorite last year, so I don't think you'll have any trouble picking up on them. They are going to get a lot harder as we go along. All right, 15, new whiteboard. All right, 15. Okay, these have a lot of words, but I don't want you to read the words. I want you to go right to the end where it says make a sketch of the graph with a reciprocal function g of x equals 1 over the square root of x. So g of x equals 1 over the square root of x, like that. Let's see, what do they have? Okay, they have the regular square root function graphed. So they have f of x equals the square root of x, and that function looks like this. It looks like that. That's a square root function. We're doing the reciprocal function. You don't have to read anything they say. All I want you to do is make a chart and pick a few points and try to make sense of it. So here we go. Here's our graph. So let's pick a few points. If we put in 0, it's undefined, so we can't use the 0. So x can never equal 0, so we call that our asymptote, because we have to draw a line. Later we're going to be dealing with asymptotes, x can never be equal to 0, so it's never going to cross, I'm not going very straight, it's never going to cross this line because x can never equal 0. So that's why we call it an asymptote. So we're going to pick some points. Let's put a 1 in. If we put 1 in, we're going to get 1 out. If we put, now it's a square root, so I'm going to pick numbers that are perfect squares. I can't put any negative numbers in because we'd have a negative under the radical. So we're not going to have any negative x values. So the whole way out here, there's not going to be any graph out here at all. So I'm going to pick a 4, and then we're going to 2. Oops, actually we're getting a 1/2. And look what happens. When I do 16, I'm going to get 1/4. Can you see what's happening to the fraction? Let's just do another one, though I'm not going to plot it. 25, I'm going to get 1/5. It's going to keep getting smaller and smaller and smaller until it almost touches x, but it's never ever going to touch x. And if I kept putting in like 1/2, I would get bigger numbers. If I went numbers smaller than 1, it would just keep getting bigger and bigger and bigger, but it would never hit the y-axis. So once you can see that, you don't need a lot of points. So let's make these a little bit smaller here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So we get 1, 1, which would be about here. I'm going to raise that up just a little bit. We'll change our scale. 1, 1. When I put in 4, 2, 3, 4, I'm going to get a 1/2. And when I put in 16, I'm going to get closer to the axis. You can see you don't need a lot of points. You just need to have to understand what's going on. So it's never going to touch that axis. That wasn't a very curvy curve. And it's never going to touch the x-axis. And you put arrows on there, and that's what your graph's going to look like. Only it should be a little bit more curved than mine. All right. Those aren't scary. Just pick, 3 points would do it. I mean, you could almost get by with 2 points if you know what the graph's going to look like. All right, here's our dreaded number 17. I don't know what to do to get this to stick in your heads. I mean, they're just weird, and I understand. So we have the square root of 2x plus 6 all over 4x squared minus 4x minus 3. So we cannot have a negative number under the radical. So let's start with that one. So if it can't be negative, it has to be greater than or equal to 0. So anytime there's a radical in the numerator, you just say it has to be greater than or equal to 0. If there's a radical in the denominator, it cannot be equal to 0 either because you can't have 0 in the denominator. So you just solve this. 2x is greater than negative 6. X has to be greater than or equal to negative 3. So that's the case for the numerator. We have to find out the case for the denominator. Well, denominators can't equal 0. So we have to figure out what values will make it equal to 0. It's quadratic, so you have to factor it. So we're going to get, let's see, I already factored this one. So it's going to be 2x plus 1, 2x minus 3 equals 0. So you'd say 2x plus 1 equals 0. 2x minus 3 equals 0. 2x equals negative 1. X equals negative 1/2. 2x equals 3, x equals 3/2. So it has to be greater than negative 3, but it can't equal these numbers, so you're going to make your set. You'd say x is an element of the reals such that x has to be greater than or equal to negative 3, and x cannot equal negative 1/2, and it cannot equal 3/2. And that would be all the values that would be true for this. If you had a number like negative 4, it would make the numerator negative. So, and these are the two values that make the denominator equal to 0. Wow, these are taking up a lot of space. 19. All right, let's do 19 on this page. All right, so they're saying r of x equals the tangent of x. S of x, these are functions, equals the cosine of x. And then they give us this little problem. They say 3r of x, whoops, no, they don't say that. They tell you what x is. 3r of 180 degrees plus 2 S of 30 degrees, and you're supposed to evaluate that. So what you do is, this is R of 180, so, oh no, my connection just got lost. There. All right, so, whoa, when it lost connection, it lost my colors. All right, so you go to the R function and you replace the x with 30. So I'm going to say 3 times the tangent of 30. See, I went up here and I'm replacing the x's with, whoops, 180, not 30. 180, 180, 180. So it'd be tangent of 180 plus 2. Now we go to the s function and we put the 30 in where the x is, so we'd say cosine of 30. Now something new, you must have learned this. Let's see in the book if it tells us where you learned this. This is number 19. This came from lesson 24 and 29. All right, the thing with this one is this is called a quadrantal angle because it lies on a quadrant. And I'm going to show you real quick how to figure out quadrantal angles. So we're going to have other tricks later. We're going to be graphing these and you're going to be able to see the graphs. So 180 degrees, this would be, let's go, we're going to do a circle kind of with a 1 degree radius, 1 degree all around here. So if we put the coordinates of this point, this would be 0 degrees right here, right? 0 degrees. The coordinates would be 1, 0. This is 90 degrees right here. So the coordinates of this would be 0, 1. This would be 180 degrees, so the coordinates would be -1, 0. And this one would be 270 degrees. The coordinates of this one are -0, -1. All right. These are quadrantal angles, and the distance out is going to be 1. So this is called the unit circle. A unit is 1. So if you put a circle going the whole way around here, these would be the coordinates. Now when we're talking with these coordinates, this is your x coordinate, this is your y coordinate. This is associated with cosine, and this is your sine. So if I said, what's the cosine of 180 degrees, 180 degrees, you would just say -1. If I said, what's the sine of 180 degrees, you would say 0. The cosine is the x coordinate, the sine is the y coordinate. If I said, what is the cosine of 90 degrees, you would say 0, because that's your x coordinate. What's the sine of 270 degrees? Well, that would be the second coordinate. The sine would be -1. This one's asking for tangent. Tangent is your y over your x. So it would be 0 over -1. So the answer to that would be 0. Tangent is y over x. It's undefined here because if you did y over x for this and over this, you would have 0 in the denominator. So tangent of these two, 90 and 270, is undefined. But the tangent of 180 degrees is 0. Now we need 2 times the cosine of 30. So let's make, that's not very good 30, but it's going to do. So we do 1, 2, √3. Cosine would be opposite over adjacent. So it would be, it would be adjacent over hypotenuse. So square root of 3 over 2. And this is times 2. These cross out, so your answer is √3. Yeah, a little tricky. We'll probably come back to this. All right, let's go to the next whiteboard. This is longer than I thought it was going to be. All right, 21. I'll set this up, but I'm assuming these kinds you can kind of do, right? Equals 9. So that's a circle, and this is a straight line. You can try to visualize what it's going to look like. We can do that. I guess you guys can fast forward, so it doesn't matter how long this video is. And we have some sort of straight line. Let's see if they have a picture of this in the book. No, they don't. So I don't know which direction. The slope is going to be negative. So it's going to be a negative slope, so let's just put it through here. And you're trying to find out where they intersect. So you're trying to find this point and this point. Now, sometimes you can add the two equations together and eliminate a variable, but this doesn't work because these are squared and these are not. So it's usually if you have if they're all squared, you can do that. So I'm just going to solve this one for x. So we get x equals 9. I'm going to do y minus 9. No, 9 minus y. And then we take and we put it up here, 9 minus y, quantity squared equals y squared equals 9. And we're going to work all that out. And so we're going to get 81. The mature way to do this is take these two together, negative 9y, and multiply it by 2, so you get negative 18y plus y squared. And then you would have, seems like I did something wrong here. X squared, oh, this should be minus y. If I'm going to put it up there. Minus y squared equals 9. And these are going to cross out, and we get negative 18y equals negative 72, and you get y equals 4. And then you just put the other one back in. I guess this line only went through one point because we're not getting two solutions. So we put the 4 in here and we get x equals 5. So it looks like the circle only intersected in one point instead of two. So it must have been more like a tangent line. All right, 23. All right, I feel like you could get the rest of these pretty easily. 3a over b minus 2b over a all over ab over c plus c over d. This is where you're going to just multiply everything by the common denominator, which would be a, b, c, d, a, b, c, d. So the b's would cross out, and I'm going to not finish that one because I think you can do that one. If you have trouble on that, let me know. All right, 25. Divide. We did those in class. I'm not going to do another one. Let me see. The book does a pretty good job at showing that. 27 solved by completing the square. All right, real quick. 4x squared plus 3x minus 2 equals 0. You have to divide everything. You can't have a coefficient in front of your x squared term, so you're going to get x squared plus 3/4 x. And I'm going to throw that 2 on the other side and divide it by 4. Let's see, such as that, right? All right, so it's going to be 1/2 over there. We're going to divide this by 2 and square it, so it would be 3/8 squared. So we're going to add that to both sides, which is going to be 9 over 64, 9 over 64. This is now a perfect square trinomial. So we can factor it, x plus 3 over 8, quantity squared. And if we add those together, we get 41 over 64. Take the square root of both sides, so you get x plus 3/8 equals, plus or minus the square root of 41 over 8. And your final answer is x equals negative 3/8 plus or minus root 41 over 8. And that's it. The factoring ones were odds, and I don't remember which ones you had from lesson 29, but we'll just go with that. Okay, so that's it for most of the problems in lesson 31.